Hey guys, in this video we're looking at linear inequalities in two variables. And so all the graphing lines that we did in the last few sections are going to come into play here, but it has this kind of additional thing of having this less than greater than, which definitely makes it a little bit harder. So our first step on these problems is basically just graph the line. And in terms of graphing the line, there are a couple things we need to know. If you remember back in the earlier section when we did inequalities, when we had greater thans and less thans, we used an open dot to denote the endpoint, to say it wasn't included. For a linear one where we're going to draw a line, we're going to use a dashed line to indicate that kind of open hole idea. And then if we got the equals to kind, that used to be a solid dot on just a number line. So when we graph those, we'll graph those using a solid. So, and then there's going to be one more step after that, but let me get this graphed and I'll talk about that piece. So here we got this equation. It's in standard form, which means the x's and y's are on the same side. For me, the easiest way to do this, and man, I'll see people like move the 2x over and divide out the -5. And when they divide that -5, they almost always forget to switch the direction of the inequality because it's just kind of a funky problem. So I wouldn't go through all that. I would do this. If x is 0, you can just cover that up because 0 is going to make that gone. -5 times something makes 10, so that's got to be a -2. And if y is 0, you can just cover this up, and -2 times something makes 10, so that'd be -5. And to me, from standard form, intercepts are the way to go on this. So I'm just using the graphing by intercepts that we learned earlier. Wouldn't do it here. If I'm slope intercept, I'd much rather use the slope and the intercept. But if I got that, this is pretty good. So let's see. If x is 0, y is -2. So when x is 0, y is -2. And then x is -5, 3, 4, 5 when y is 0. And I just have to be careful to draw a dashed line. So something kind of like that. And then there's this whole greater than less than thing. I dealt with the fact it wasn't equals. I did the dashed line. But what's going to happen on these is we're going to shade either one side or the other. And I'm going to kind of diverge for just a second and go back to number lines and just kind of point a thing out to you. If I have x is less than 3, for instance. So here we are. There's 3. And say there's 4 and there's 2. If I put 4 in that equation, is 4 less than 3? No, that comes up false. And that's not the way I'm going to draw the line. I'm going to have my endpoint right here on the 3, which is like what this boundary is here. And if I put 2 in, 2 is less than 3, so that makes it true. And so we would draw our graph this way. So if we tested a false point, that wasn't the way our graph went. When we test a point and it's true, that is the way our graph went. Of course, when we were graphing these earlier, we just said x is less than 3 and knew it went that way. But here it's not really as clear as to which side of this graph is the side that's shaded and which side isn't. And so what we're going to do is we're going to use a test point, which is kind of what I just did here with the 2 and the 4. So, I don't think I assigned anywhere it goes through the origin. But basically, I'm just going to use the origin. I'm going to use this point right here, 0, 0. And I'm going to see if that comes up true or false. So if it comes up true, that means this is the side that gets shaded. If it comes up false, then it's like that 4, so I should shade the other side of the graph. And you can use any point you want. I go with 0, 0 just because it makes it really easy, because I'll write it out this time and then I'll shortcut it for the next ones. But you can see I didn't need to do any of that, right? Because 0 times who cares, 0 times who cares, it's just 0. And then greater than 10. So you can just look at the side and go, oh, it's going to be 0 greater than 10. You don't have to do very much math. So that's why I like 0, 0. So 0, is it greater than 10? Yeah, not so much, right? So that is false. That did not work out for us, which means this point is a big old no. That didn't work. So it's like that 4. So if this side didn't work, well, there's only one other side, which is down here. And so that's going to be the side that you would shade on the graph. So in terms of getting these things in the computer, the way you graph it is, you'll have a cursor and you'll click on the 2 points and that's going to draw the line. And you'll see below there's an option for a solid line and a dashed line. So you click on dashed line, click your 2 points, and then if you move the cursor to either side of the line, it will highlight. But you have to actually click down here somewhere in this area to fix the highlighting. Otherwise it's not fixed, it's just floating back and forth. So click twice to set the line, and then click a third time to set the highlighting, and then hit submit, and it should work. So that would be that one. This one is same idea, but this was in standard form, so now we're in slope intercept form. So now for me graphing this one, I'd start on my 3, because that's my y-intercept. And then my slope is -4. So that's like -4/1. Remember our rise and our run from a couple sections ago. So it's gonna rise -4, so 1, 2, 3, 4, and run 1, be right there. This one does have an equals, and so it's gonna be a solid line. And then we have to figure out which side to shade. So I'll put in 0, 0 like I did up here. So this was, I tested 0, 0. So that's what I'm gonna do here again, is test 0, 0. So 0 is less than or equal to -4 times 0 plus 3. So 0 is less than or equal to, that drops out 3. And so 0 is less than or equal to 3. Yep, 0 is less than 3, so that is true. And then that means we're going to shade the side with 0, 0. So this time I tested this and it was, yes, that did work. So I shade with the 0, 0. The other thing on this one, I went through and I did the whole test point thing, but if I ask you, where are the y values less than this line, does it make sense that it's going to kind of be below the line, right? And this line's kind of steep, but if you think of it, you know, not being so steep, where the y's are going to be less than this thing is underneath it. And so you can also kind of, when you're in slope intercept, you can use that idea and get it shaded. Likewise, if this was the other way, it would be say, where are the y values greater than the line? So then I would want to shade above the line. Or you can also just use a test point. So these next two are the horizontal and vertical line ones. So here we got to remember back that x equals 5 is a vertical line through 5. So our boundary would look just like that. And then shading, this just says, this is the same thing, you know, if I think of this x greater than or equal to 5, I would be solid dot going this way. It's nothing different. This side is where all the x's are greater than 5. So that's where we would shade. And then for y less than 2, so we're here at 2, horizontal line, and it's going to be dashed because it doesn't have an equals. And then where are the y's values less than 2? Well, anywhere below it. So no real need for a test point. And that would be where the y's are less than 2. So these next 6, I think, are all the ones I would have you guys do in class in a lecture section. So these first couple examples are in standard form, so we'll practice kind of doing intercepts here. So x, y. So I'm going to say when x is 0, this is gone. -4 times what would make 4. So if I divide that over, I can say I got a -1 right there. And if y is 0, then just x equals 4. And as I'm doing this, I'm ignoring the greater than less than. I'm just thinking of it as equals because I'm just trying to get the boundary. So when x is 0, y is -1, and when x is 4, y is 0. This is a greater than, so no equals to, so I just have to be careful to use a dashed line there. So it should be about something like that. And then if I test 0, 0, I'm going to have this whole side will just be 0 and then greater than 4, and that is not true. That's false. So this point right here, that's a no. So no, that didn't work, which means we must be shading underneath there. Number 6, we got, doing a little table. When x is 0, -4 times something makes 20, so it'd have to be a -5. I think it's division if it helps. If y is 0, that's gone, so 5 times something makes 20, so it must be a 4 right there. And then we can just get that graph. So when x is 0, y is -5. And when x is 4, y is 0. So that is going to be a solid line. And let's see if we test 0, 0. So I put 0 on this side, and 0 is greater than or equal to 20. False again. And so I don't shade this side, and I do shade this side. So then here's a couple examples in slope-intercept form. So here my intercept is 3 and my slope is -2/1. So it's going to be rise is -2, run is 1. Has an equals, so I want to use a solid line. And then once I have that, I can do my test point. Or I could just think where are the y's less than the graph, so it's going to be underneath, but just to show that, if I test 0, 0, I get 0 is less than or equal to -2 times 0 plus 3, or 0 is less than or equal to, that's just 0, 3, that's true. So again, kind of show who to shade this side, and that would be your graph. So it was true. That's a bad looking U, but there we go. This one we got a 3, and then we're going to go, so -4/5. I always think of that negative as going in the numerator, just because I like my 5 to go to the right, and then it says we would go down 4 from there. And then this one will be dashed. There's no equals. And then where the y's greater than this line would be above. But again, if I kind of put in the zeros, so 0 would be greater than, this would just be 0 plus 3. 0 greater than 3, no. So shading above the line. And then these last couple are vertical and horizontal again. So x less than 2, so that's a vertical line. Remember, they're backwards intuitive. That means the x's are always 2 no matter what the y's are. And the x's are going to be less than 2 on the left-hand side. So that's just shading this way. And then finally, y greater than or equal to 3. So where the y is greater than 3, it'll give us a solid line through 3. And then they're going to be greater than that up above. Cool. So that concludes linear inequalities in 2 variables.